roots of a complex number. Suppose x plus iy bracket square equal to a plus ib, where x, y, a, b are real numbers. Then x plus iy is a square root of the complex number a plus ib. X plus iy bracket square equal to x square minus y square plus 2ixy. Therefore, x plus iy bracket square equal to a plus ib gives x square minus y square plus 2ixy equal to a plus ib. Equating the real and imaginary parts separately, we have x square minus y square equal to a and 2xy equal to b. We solve these equations for x and y to get the square root x plus iy. We also note that minus x minus iy bracket square is also the same. Hence, minus in bracket x plus iy is also a square root of a plus ib. Thus, a complex number has two square roots and they are negatives of each other. Last but not the least is representation of complex numbers in the plane using Arrogance diagram. Let z equal to a plus ib be a complex number. If b equal to 0, the complex number reduces to a real number a and hence can be represented by the point a0 on the x-axis. If a equal to 0, the complex number reduces to an imaginary number ib and can be represented by the point 0b on the y-axis. In geometrical representation of a complex number, the real part is represented on the x-axis and the imaginary part is represented on the y-axis. Hence, the x and y-axis are respectively called the axis of reals and the axis of imaginaries. The figure representing a complex number a plus ib by means of the point a comma b in a plane with reference to the axis of reals and the axis of imaginaries is called Arrogance diagram. Modulus and amplitude, that is argument of a complex number. The first, modulus. Let z equal to a plus ib be a complex number. Then it is represented by the point p, coordinates are a comma b, in the XOY plane. We have length OP equal to root a square plus b square. Definition: if z equal to a plus ib is a complex number, then we define root of a square plus b square to be its modulus. Thus, modulus is nothing but distance of the point representing the complex number from the origin. It is denoted by r. Therefore, r equal to mod z equal to mod of a plus ib equal to root of a square plus b square. For example, if z equal to 2 plus 3i, then modulus of z equal to root of 2 square plus 3 square, that is root 13. Now amplitude, which is also called as an argument. In the figure, if ray OP makes a directed angle theta with the positive direction of the x-axis, then theta is called the amplitude or an argument of the complex number z equal to a plus ib. Let length OP equal to r and major angle XOP equal to theta. From the figure, in right angled triangle OAP, sin theta equal to b upon r, therefore b equal to r sin theta. Also, cos theta equal to a upon r, therefore a equal to r cos theta. Clearly, r equal to root of a square plus b square. Definition: the angle theta which satisfies the equations cos theta equal to a upon r, that is a upon root a square plus b square, and sin theta equal to b upon r, that is b upon root a square plus b square, where minus pi less than theta less than or equal to pi is called the amplitude or an argument of the complex number a plus ib. Clearly, sin theta upon cos theta equal to b upon r upon a upon r, that is b upon a. Therefore, tan theta equal to b upon a. This formula is useful when theta is not a standard angle. Argument z is defined only for non-zero complex number z. If a equal to 0 and b not equal to 0, then theta is either pi by 2 or minus pi by 2 depending on the sign of b. Since a equal to r cos theta and b equal to r sin theta, we have z equal to a plus ib equal to r into in bracket cos theta plus I sin theta. This is called polar form or trigonometric form of a complex number z equal to a plus ib. Finally, a rough sketch of the number system.